Okay, so what we're going to do today is the last piece, which is sort of where we're going to really practice writing exponential equations. And just so you know, I've been going into the delta assignment and trying to give you guys some credit back, because one of the things you have to be very careful of is when you're writing an equation. What is an equation, guys? An equation has an equal sign, right? So when you go to write your equation, please don't forget your y equals when you're writing your whole equation, okay? And so I've been trying to go back to give you partial credit, but if you didn't have y equals typed in there, today you'll notice when I made the homework, I put the p equals already, because we're going to see word problems, so it's not always y and x as our variables, right? So just pay attention. When you have to write an equation, you have to write the whole thing, not just this part. The equation is the entire piece, including the equal sign. All right? So here's our equation today. This is for any sort of exponential function that's doubling or you're cutting it in half. So this is just regular numbers, right? So if you have regular numbers like double, which would be 2, right? Timesing by 2. Or if you have to triple something, you would just stick that number right in there as the b value. Half, if you have to take half of something, right? You just plug those, what am I doing here? You just plug those right in. So what's the only weird thing? If you are ever given a percent, okay, you can't just stick the percent in there. The percent has to be changed to a decimal, and then to make it growth, you either do 1 plus that decimal, or to make it a decay, you do 1 minus that decimal. And I was actually very shocked to see how many people chose the wrong thing on their homeworks, whether a problem was growth or decay, because the words literally represent growth or decay. So please don't make silly mistakes like that. That's an awful way to lose points on a homework. So do you see this word increase, guys? This means this is going to be a growth problem. And it's percent, which means I have to add it to 1. Why add it to 1? Because it's increasing. And we need our b value to be greater than 1 if I want to be an increasing growth problem. All right, so what are we going to do today? Just practice writing equations based on these easy word problems. They never get harder than this. And then we might also, after we write an equation, use it to see what happens after so many years. Okay? And we don't have a lot of problems, so let's get good practice so you can get right into that homework I made. Okay, the current population of a town is 10,000 people. Also, please know I went back into the homeworks and gave you credit. Delta is super touchy. So if you typed 10,000 like this into that equation, but I made it where my answer had this without the comma, it would have marked you wrong, but I went back in and gave you guys credit. So please know things like that are touchy. And just email me and I can go back in and give you credit. Be like, Miss Martin, I was right. I just put a comma there, etc. So we're starting with, which on paper it doesn't matter, right? Comma or no comma, your paper is just a number. Okay, so we're starting with 10,000 people, so that's your A value. And what's happening is this population of people is increasing by 20% each year, okay? So what we're doing is we have to do 1 plus that 20%. You with me so far? Now, of course, we have to exchange the y and x for their variables, which are p and t. So the total population y equals, so p equals 10,000, comma or no comma, doesn't matter. But in delta, it does matter how you type it. But don't worry, Miss Martin will give you credit. Okay, now the 20% has to be changed to a decimal. So what is 20% as a decimal? Well, 20% is also known as 20 out of 100, right? And you can let your calculator move that decimal point for you, which would be 0.20. And what we need to do is 0.20 is less than 1, isn't it? And so if we don't put that 1 in front of it, this would not be a growth problem, which is what we need it to be. So it's going to be 1 plus 0.20, or in other words, 1.20, right? And it's after how many years? So they want us to use t instead of x. And you can leave your equation just like that, or you can actually combine that. Comma or no comma, just make sure you have enough zeros. And there you are. So either of those equations are correct. And that's all we had to do. which equation would be used to find the population after 2 years? This one. So if I wanted to know what the population of the town is after 50 years, I would just plug a 50 in here and go do the math in my calculator, or go type that in my y equals and go to the table and see what happens every year. Okay, so there's your equation. How easy is that, right? So percent has to be changed to a decimal, then interpreted. All right, let's try this one. Kathy plans to purchase a car that depreciates. Okay, this is a losing value one, and they gave us a percent. So that means I either do 1 plus that percent or 1 minus that percent. And because this is a problem where this keeps getting smaller, I'm going to want to subtract this percent from 1. Okay, because this is a decay problem. So we're going to want to use this. The initial cost of the car is 21 grand, and it loses a rate of 14% per year. Okay, and what equation represents the value of the car after 3 years? So let's first write the equation, then figure out the after 3 years part. Okay, so first off, y equals a times b to the x. And our b value has a little work because we can't work with percents. So the first thing is we have to change percent to a decimal. So 14% is also known as 14 out of 100, which as a decimal is 0.14, right? Just go in your calculator and divide 14 by 100. And then because I need this to be a decay problem, I'm going to subtract it from 1. Okay? So we're starting with, ready? $21,000 car, and we keep subtracting 14% off of that 21 grand. Okay? So let's clean it up using their variables. Okay? And so let's see which equation represents the value V of the car after 3 years. So the value of the car equals $21,000. And 1 minus 0.14, let's just clean that up, is 0.86. And they want to know after, and write the equation for after 3 years. So we're going to put a little 3 here. And just for sakes of, because that's a weird question, typically you would evaluate that. What is, if you had a $21,000 car and it loses 14% for 3 years, what would we be at? Okay, here's where you guys have to contemplate rounding. Okay? After 3 years, here's what we have. This is money. So I like all these whole numbers, and it doesn't say any rounding because money you would traditionally round after a nearest cent anyways. So let's, Mommy's teaching. Okay, here you go. Go away. All right. So 57 point, and obviously there's not 3 decimals in money, right? So that'd be 0.17 cents, but that 6 makes that 17 cents and 18 cents. And so that's about what her car will be worth if she wants to sell it 3 years later. Okay. So here's our equation. Here's what would happen if we wanted to evaluate what happens after 3 years. All right, let's do another one. A high school sponsored a badminton tournament. After each round, half the players are eliminated. If there are 64 players at the start, which equation models the number of players after 3 rounds? Okay, so exponential. I'm starting with 64 players, and I'm half is not a percent, is it? It could be 50%, but 1/2 is just a normal number, so I'm just going to go and put that in. So this is not a problem where you have to worry about the percent signs. And so half, because half is a number that's already something we can work with. And then here's your equation. Okay. And then if they want to know what happens after 3 years, 2 options. You can go type this in your y equals and go look at your table, or just do the math in your calculator. What happens, how many people are going to be left after 3 rounds? So let's see. 64 people, and we keep eliminating half, or 0.5. And what happens after 3 rounds? We'll be left with 8 people. 8 players will be left after 3 rounds. This is your equation. All right. Good so far? So remember, if it's not a percent, you just take that number and put it in there. All right, I love this problem here. This is actually, both of these are Regents problems. All right, let's look at number 4 together. Okay. Rachel and Mark were given, I'm going to take you to your friend's house. Rachel and Mark were given the information shown below about the bacteria growth in a petri dish in their biology class. All right, and so here's the table and here's what's going on. After 1 hour, this is how much bacteria is in the petri dish. After 2 hours, after 3 hours, etc. Rachel wants to model this information with a linear function. So she's saying that this is linear. Mark is saying this is exponential. Which model is a better choice, and explain why you chose this model. So do you think that this is linear or exponential, and how do you know the difference? So let's recall some information here. To be linear means that it's constantly going up by a constant number. Like you keep adding something, adding a number, or keep subtracting a number. Okay, you keep constantly adding or subtracting something. If it's exponential, it keeps growing at an exponential rate, which means there's a multiplication factor. So you keep multiplying by a factor. Okay? Never division, guys, because we always have to multiply by something. So if it looks like division, like if it looks like it keeps dividing and getting smaller, it's because you're multiplying by a fraction. Okay, so let's see what's happening here. How do you get from 220 to 280? That'd be plus 60, right? If this is linear, you would add 60. And is it true they keep adding 60? So what's 280 plus 60? Ready? 280 plus 60? That would make 340, which is what? Not what we have. So automatically, nope. See how we keep going up by 1? So first make sure your x's are going up constantly. And we want this to keep going up by 60. And we saw right here, if I added 60 to 280, it's not 350. So this is automatically not linear. So how do we find what I multiply to get here? Well, if 220 times what is 280? If you divide 280 by 220, you'll know what you multiply by. So divide 280 by 220, or any number by the one before it, and you'll know the growth factor. So 280 divided by 220. And it's 14/11ths. And I know that's like a weird number to keep multiplying by, but let's go see if it's right. Okay, so it makes sense to keep multiplying by 14/11ths. So ready? What's 220 times 14/11ths? What the? Get over there. I get 280, okay. What's 280 times 14/11ths? Not 350. So what did I do wrong? Did I divide wrong up here? Because that could happen. 280 divided by 220. Could they have rounded? Yep, they probably were rounding. So here's what's weird about this one. We knew it wasn't linear because it didn't keep adding 60. So because there's only 2 options, it has to be exponential. So let's write this first. Okay, I know this seems weird. I forgot about how weird this problem was. This one was on a Regents probably 7 years ago or so. So exponential, because the table does not keep growing at a constant, right, rate. So because it's not constant, that makes it exponential. And because it's not necessarily 14/11ths that we keep multiplying, but it's about 14/11ths, because sometimes exponential the growth can keep changing a little bit, but we notice that it does grow different amounts between each value, and it gets bigger faster. So that's why we're going to say exponential. And it does say which model is the better choice. It doesn't say the correct choice, but the better one. So exponential is the better option here because it's definitely not a linear constant growth. It is growing at a bigger change between as we get higher up. Okay. So a weird one, but that's all you have to say, and that's a 2-point problem on a Regents. Okay. Michael has $10 in a savings account. Option 1 is that he will add 100 to his account each week. Option 2 is that he will double the amount in his account at the end of each week. Write a function in terms of x to model each option of saving. All right, option 1. Option 2. Option 1 is that if he starts with $10, he will keep adding $100 in his account each week. If you keep adding 100, is that linear or exponential? That would be linear, right? And so this is your y-intercept because you're starting with $10. So think of your equation of a line. So your 10 is your y-intercept because you're starting with $10. And then he keeps adding $100 in his account each week. Okay, so there's option 1's equation. Option 2 is that it will keep doubling. Okay, so if he starts, so that's exponential. Because doubling means you keep multiplying by 2, right? And multiplication represents exponential. And so the equation of an exponential function is a times b to the x. This is not a percent, so I don't have to worry about that b value at all. I just literally put the double in there, which is 2. And so we're starting with $10. I keep doubling the amount of money. And there we are. There's my 2 equations. Okay? Michael wants to have at least $700 in his account at the end of 7 weeks to buy a mountain bike. Which option will allow him to reach the goal? Now, you guys probably already know which one it's going to be because which one is going to grow your money the fastest? Exponential is always quicker than linear, right? Maybe not at the beginning, but eventually exponential will surpass linear. So if we wanted to know, what we could do is go to our graphing and go to our y equals, and let's see what happens. So if I type the linear one in, 100x plus 10, and I want to know what happens after 7 weeks, right? At the end of 7 weeks, he wants to buy a mountain bike. After 7 weeks, okay, he will have $710. So y equals 100x plus 10. So after 7 weeks, he will have $710. Okay, so there's the option 1. And now let's look at option 2. Let's go use our calculator here. And the equation is 10 times 2 raised to the x. And after 7 weeks, we're at 1,280. Okay. Now, you're looking at this and you're like, well, both of them give him $700. Well, read this. It says determine which options will enable him to reach his goal. Justify your answer. So both options will give him his goal. But of course, this one's giving him a mountain bike plus a helmet or whatever else he wants to buy, right? But that's not what it's asking. It just says which options will help him reach his goal. Justify your answer. We justified by showing work. That's what that means. Both options allow him to have $700 after 7 weeks. Okay. And that's it. So here's what I want to do. I think there was a problem I wanted to do on the homework, so if you want to just write it down with me, that'd probably be easiest so you can follow along. So I'm going to take you into my Delta account real quick. Oops. Edit assignment. Okay, today is EF7.
Oh yeah. Mommy, you have it.
Okay, so what I did was I designed it to follow our notes. You're going to write the equations, but notice I did put P equals, so it's your job to put the percent into a decimal, either add or subtract from 1, etc. Okay, this is great practice. This is a really good homework. I made them all. And then I think it was it this one? Nope. Thought there was one I wanted to do with you, but maybe not. Nope, I think we made it pretty self-explanatory. I think you guys should be all set. Okay, so I want you to really focus on today's homework. I haven't quite decided how tomorrow is going to look, so obviously you know you'll check your post in the morning, so I don't really have information to tell you right now, because I'm kind of on the fence of how I want tomorrow to look. But anyways, just go ahead and look into Google Classroom tomorrow, and you'll know what tomorrow is expected of you. And then today, take this homework seriously. You still have a good amount of time, so feel free to stay in this Zoom while you're completing this homework in case you have questions, or feel free to rejoin it if you have a question. It's open till 11, okay? But you guys are all set to start your homework.
Hello. Hello. Hey, work.
All right, get down. William, what did Mommy tell you? What did Mommy tell you? Would you like to go to your friend's house? You want to go to your friend's? I can take you.
No.
Well, what do you do when Mommy's working?
Yeah.